I need a medium like this, therefore the triglycerides in this case will react with water, but to react with water it needs an acidic medium, and I will leave it recorded on the arrow in acidic media. Who is it going to react with? I said just with the water. And the water molecule, what it is going to do is break the bonds. Which bonds were formed previously, that is, the bond between the carbon and the oxygen of the ester bond is broken. These were the ones that were formed when triglycerides were obtained. Therefore, to break 3 bonds, 3 water molecules will be needed. In order to understand what is happening, we need to remember that the water molecule is made up of 2 hydrogen atoms and 1 of oxygen. We can represent it this way and remember that water in aqueous solution partially dissociates and dissociates into hydrogen ions. Hydroxide ions, these are the hyphens that will be incorporated into the bond. Once it is broken, therefore we can think that in this molecule, the hydrogen is going to be incorporated into one of the 2 parts of the broken bond, and the hydroxide group will do so in the other. Therefore, we are going to think inversely of the formation, and to think inversely of the formation, I have to remember that when form a wound list part of the glycerin and a fatty acid, therefore if this reaction is the reverse, the formation I will obtain as a product glycerin and fatty acids, then to the part of the molecule that comes from the glycerin, that is to say, all this I must incorporate the hydroxide groups, therefore, of the water molecule. In the hydroxide part it will join the carbon. I mark it again so that it remains with the same color. The hydroxide part joins the carbon, and the cation hydrogen is going to be incorporated into the lazio, to have as many acid molecules as there are radicals, so to have in this case a triglycerides, I have 3 acid radicals, 3 of the same, therefore 3 molecules of fatty acids are going to be formed. And therefore, I will have the following molecule left, of glycerin. And this is where the 3 hydroxide groups that come from 3 water molecules are incorporated, and I will have 3 molecules of fatty acid left, which in this case is lauric acid. And I am going to add them here with the same color used previously, so that you remember that it incorporated the hydrogen that comes from the water molecule. The lauric acid molecule has 12 carbons, so it is carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 2. Therefore, after acid hydrolysis, I obtain glycerin. Ha being lauric, the reduced formula would be Ce12O. Let us remember that it has 12 carbons without any double bonds, and for the equation to be complete, we should set 3 fatty acid molecules to be formed. The equation to be complete, we should set 3 fatty acid molecules to be formed. The equation to be complete, we should set 3 fatty acid molecules to be formed.